Hello and welcome everyone to Pomodoro Joe for Monday, January 9th, 2023. And today we'll be doing LeetCode problem 144, binary tree pre-order traversal. Before we get started, I'm going to set 25 minutes on the Pomodoro timer here. So, binary tree pre-order traversal. It's an easy problem and the problem statement's pretty straightforward. Given the root of a binary tree, return the pre-order traversal of its node's values. Okay, so for this problem, you will need to know what a binary tree is, you'll need to know what preorder traversal means, and you'll probably need to know what recursion is and how to do recursion. So in this case, preorder traversal just means that you visit the node itself first, then you visit its left child, then you visit the right child. So for this example here, the node itself is 1, the left is none, so the right is 2, and its left is 3. So this should be 1, 2, 3, and as the example shows, that is the answer, 1, 2, 3. The other examples, not super helpful, empty node, or a single node with no children. All right, so this is pretty straightforward. Preorder traversal. Do the node's value itself, then left, then right. So we'll jump in and do this recursively. So anytime I see a tree traversal problem, especially binary tree traversals like this, it's pretty straightforward to do this in a recursive manner. So we'll have some result, and that result is going to be an empty list to start with, and we will add to it as we go along, and then at the very end we will return our result. Okay, the first thing you want to do anytime you have a recursive algorithm is to think, what is the base case? How do we break out of the recursion? So in this case, you can see this root node is an optional tree node. So our base case is, what if we don't get a root node? So we'll say if the root is equal to none, then we will return our result, which is just an empty list. And that matches up with our example 2 right here. All right, now in preorder traversal, we will do node, then left, then right. So I will put that here. Preorder equals node, then left, then right. So we'll first want to append our node's value to this result. So the result append root.value. So that's the first step. That's in preorder. Next we go left. So then the result, and this is where the recursion comes in. We will append. So in this case, I'm not going to do append. I'm just going to say result is equal to result plus. That's easier than doing an append with each of the elements of our return value. So in this case, this result, because it's a list, and we'll be adding the result from preorder traversal left. So we'll go ahead and call this self.preorder traversal on our left node. So that's going to be root left. So this plus is going to extend the result with all of the elements from the return value of this call. So we're going to do result is equal to result plus the call on the left, and then we'll do result is equal to result plus self.preorder traversal on the root right. And that should be it. So we start off with some result that's an empty list. If we don't have any node, we will return that empty list. Otherwise, we have some root node, we'll grab its value, put it in the list, and then we'll put the left's value, we'll call a recursive call of preorder traversal on the left and preorder traversal on the right, adding those to our result, finally returning the result. That should be it. Oh, I have some, I called this value when, if we look up here, it's just called val. All right. Try that one more time. And that works. And we'll submit this and see how well we do. Not too bad for just a couple lines of code. And we pass all the tests, and we actually do all right in terms of time. We beat 69% of the other algorithms in terms of runtime, and beat 57% of the algorithms in terms of memory. So yeah, pretty straightforward, not too bad.